So this is chapter called Antiderivative. No, it's the whole chapter 4 is integration. 4.1 is starting the idea of antiderivatives. Antiderivatives. You don't have to write this down, but you should write down the definition while I'm saying that the goal of differentiation is to find f prime. We know that. From the function f. The reverse process called antidifferentiation, which is equally important. If you have f, you can find derivative of f, and that's what we're going to be testing you, right? But you also want to go back to f, and to go back, we will have to learn how to undo differentiation with antidifferentiation. Given the function f, we look for the antiderivative, which we are going to call capital F, and so on. So the definition is a function capital F is called antiderivative of f on the interval I if, when you differentiate f, then your original f of x shows up. So antiderivative is undoing the derivative of small f. So when you differentiate f, it gives you back this small f. Anyway, it's too complicated to explain, easier to show. So if we have speed of the asteroid, given, that's my example. I like sharing this example to people. Idea. The asteroid is going towards Earth, and we're all gonna die soon or so. There are several things we already shipped into space long time ago. For example, there's some satellites around Mars and so on. They can actually check and model the speed of the object passing by. So for example, they already send us the information that the object is passing by having this speed. The speed of an asteroid is given as this quadratic function, whatever it is. You want to know how far the asteroid is away from, just a second. How far is the asteroid away from the Earth? How much time do we have left to leave, and so on. How to find distance from velocity. Guess what? You need to find the distance as of t is distance, right? Distance, when you differentiate, gives you velocity. So it exactly means that distance is the antiderivative of the speed v of t. And in general, we will teach you that when you differentiate s of t, that gives you v. When you differentiate v of t, that gives you acceleration. But then you can always go back using antiderivatives. Antidifferentiation, which we're going to call integrals. Nobody calls them antiderivatives. It's a weird American way to introduce integration. Integrals have their own notation and have the most important application in the world. So we all teach integration in all classes around the world because there's so many applications of that. Yes?
What I was wondering is, wouldn't everything have infinitely many antiderivatives?
Very good idea. We will have to figure out that. That is very smart what you just said. So for now you don't know what is antiderivative of this equation. But let me give you some easy one. For example, try to guess. So some idea. Some functions you could guess. So what do you think? Let me see. What do you think I have to differentiate to get 2x? What was the beginning of the result of differentiation that gave me 2x? X squared, right? So you're guessing this. This is the idea without any formula, and I will give you formula in a second.
But it could easily be x squared plus 5.
Don't spoil it.
Okay.
But the question is, isn't it the same thing if I do x squared plus 5? Like Chris keeps spoiling my idea. It is the same thing. What else do you think can give you 2x? Literally anything else. Minus pi plus 73.1? Yes, it still gives you 2x, right? So that means, even though derivative is a unique process, antidifferentiation is not a unique process. Thus, antiderivative is not one-to-one. If you don't remember what one-to-one we were teaching you is, one input gives you one output, is not unique. Let's do that. Moreover, we're going to call it family of solutions. It's a family of solutions. Why they call it family? Because they hate each other? No, because they are all having the same output with a variable shifted by a constant up and down. And I'll show you this in a second. So, notation. We're going to call it indefinite integral. Indefinite integral. Indefinite integral. If capital F is an antiderivative, such a long word, nobody's using that, is antiderivative of a small f, then people just call it an integral, which is the next notation, a long, kind of looking S, but long one, tall. F of x is in between, f of x in the middle of that new notation. Dx shows up, we will have to explain what does that mean, equals capital F of x plus c, plus capital C. I'll put this in the rainbow box. That's one of the most important formulas existing in the world, seriously. So that is very important. And I'll explain you that. This is the integral sign. That means integration have started here. So when you start this long S, that means integration started. And again, if you show this notation in Japan right now without knowing Japanese, they all know what you're saying. So this is international language. How amazing is that? Then, whatever is inside called integrand. Integrand with D at the end. Each language uses different word for that, so that's different. F of x is my antiderivative, and C is the arbitrary constant. Arbitrary means any. Arbitrary constant. Arbitrary is, let me show you why. For example, integral of 2x dx. Let's see. You see the integral sign? Let me make it prettier. Integral sign. 2x, we don't put parentheses usually. 2x is the whatever we are integrating or finding antiderivative for. Dx is the end of integration. So dx shows you that integral started here. Dx means integral finished over here, and x is the variable of integration. That will be important too. As you can see, it matches. So 2x came from differentiating what? X squared. We all agree on that. But then we said x squared plus 5 also give the same answer. X squared minus pi, the same answer. So to collect all of these, we're going to add capital C, which is an arbitrary constant. C can be anything. Read this as antiderivative of 2x is x squared plus c. Integral of 2x is x squared plus c. Antiderivative is a way too long word to say. Nobody's saying that. X squared plus c. And the picture looks like this. The answer for the integral of 2x is the family of parabolas centered at 0, 0. So the original one, when c is 0, the parabola is looking like this. That is c of 0. Capital C is 0. If c is 1, it is parabola shifted by 1 up. C is 1. And they do not intersect, because it's perfect shift. If c is minus 5, well, then it's shifted down. C is minus 5. And so on and so on. It's a family of parabolas. Family of solutions. It's a family of solutions. And we're going to teach you how to use a particular solution for a particular problem. So that also will be interesting. But again, differentiation gives you a unique answer, but integration does not. And that is why integration is more complicated. And it's always like this. We learn product, not product rule, in general, 2 times 5. We learn this in school. Then we start learning undoing product. We learn division. Division has some property. Oh, don't divide by 0 or else everything blows up. So there's always like the undoing process is harder. We learn squaring things, x squared. To undo x squared, we learn radicals, square root of x. Oh, you cannot have negative numbers inside. Harder. Same thing here. We're undoing differentiation, and apparently there's a problem about that. So that is interesting to point out. So I will just show you formulas, and you will see it's going to be your favorite chapter from the whole class. This chapter is going to be your favorite. Formulas or differentiation rules. Formulas. They call it rules of differentiation or integration. No, rules of integration. And I will just show you the formulas, and you will be happy about it quite a lot. First one, integral of k dx.
What does dx mean?
So we're going to teach you more about dx soon. It means lots of small increments of the integration. I'll explain you more on Wednesday, because I can tell that people will not pay attention, not on Wednesday, on Friday, enough tonight. And so today I will just show the easy part of the whole lecture. That's going to be this most straightforward one. But good question. Dx means lots of things. Dx means the ending of the integration notation. Dx means I'm integrating with respect to x. That's important. And dx also means increments or step size. You will see it later. So when you're integrating a constant actually can get out from the integral, and you will just have k times x. But don't forget plus c. Plus c. For example, small example, integral of 3 dx is, well, you're thinking to yourself, I differentiated something and it gave me 3. What was that? Derivative of 3x gives you 3, right? But then derivative of 3x plus 5 minus 7, or plus c actually, collects all the possible answers for that. So it makes sense. When you differentiate 3x, it gives you 3. Second rule is the most popular in the whole world. Even though it might be called different names, in English it's called power rule. Everyone knows this rule. When you differentiate the polynomial x raised to the n dx. Oh wait, when you differentiate the polynomial, you know that n goes down and you decrease n by 1. Now we're integrating the polynomial and we're going to undo that process. And now you add 1 and divide by that result. So remember, differentiating, we multiply by n and decrease by 1. Now we're adding by 1 and divide by n plus 1. Plus c. That is called power rule, exactly what we had before. Power rule.
C just always shows up.
N should not be minus 1 though. For minus 1 we have a special formula. When n is minus 1, integral of 1 over x dx, that is a polynomial with a minus 1 exponent. That's a special case. And you will be surprised that your favorite function shows up. What do you think I'm talking about? Guess. What? Not yet, but we're going to do quotient rule. Your favorite formula, your favorite function shows up. What is your favorite function? It's very... Logarithm. Somehow I really like logarithm. Logarithm of x plus c. Log, when you differentiate log, it gives you 1 over x, don't you remember? So undoing 1 over x gives you log. However, x can be negative inside of the integral, but logarithm does not exist for negative ones. To avoid the situation, we put absolute value. Derivative of log is 1 over x, but undoing 1 over x gives you log of absolute value, and then of course x should not be 0. So plus c, so it's a family of logarithmic functions. Well, guess what? The hardest formula will be integral of e to the x dx. What do you think is the answer? E to the x, and don't forget plus c. That is your favorite one. That is your favorite one.
What can we do with number 2 when x equals -1?
When x is -1. That's a good question. I will do it When x is -1, it's a constant though. -1 to the n, it's just a constant, right? So the x will be -1 to the n x, right? Plus c. -1 to the n is a constant. It's not a function anymore, right?
No. I'm confused. It says number 2 doesn't work when x.
N, when n.
Oh, when n equals
And when n is -1, it takes you over here.
Of course it does. Sorry,
Right?
It makes sense now.
Good job, yeah.
I was just thinking because
I got it. Then n is -1, like so.
And it makes perfect sense why it doesn't work under those circumstances now.
Yes. There is going to be a more general case, more general, L-L-Y. If you're integrating e to the kx dx, then you still copy, but you're undoing chain rule. Remember, chain rule says multiply by coefficient k. To undo chain rule, you will divide by k. So we undo chain rule here. Undo chain rule. That's the thing, we have to learn how to undo chain rule, product rule, quotient rule. And that's what we're gonna introduce this week and next week. Use substitution, integration by parts. So that is very cool here. So just like when we learn power rule in the differentiation, product rule, it will start very small, very slow. So this is going to be your favorite chapter because it actually goes pretty slow. Let's practice. Examples. 1. What is integral of x to the 7 dx? So I want people who never took this material before to answer. If you ever did this before, it's too simple. But if it's new for you, then it's interesting. Who wants to say, what is x to the 7 when you integrate it? Chris? Yes. Go. Go. Chris, go.
Oh, me? Sorry. 7x to the 6 plus... Oh, what? It's not working right.
7x to the 6 plus c.
Sorry, my brain is backwards.
We're doing backwards.
My brain is backwards. Sorry. X is 7.
You're trying to guess, but you don't have to.
No, I know I don't have to guess.
The formula says, let me do it then. The formula says x increase by 1 instead of taking 1 and divide by that number. And I always say, don't even think what that number is, just divide by it right away at c. So, let's see.
Okay, now I feel stupid.
No, you're fine. You're fine.
I should have had that immediately.
X to the 8 over 8 plus c. Now you're doing amazing. Good job. Plus c. All agree? And now you can always check, and it's going to be only one time I will do that. The thing is, when you take exam 3, working with integration is fun because you can always check your answer. You can check by doing what? What do you think we should do to check if my answer is correct? Find a derivative of the result, and it should give me what? X to the 7, exactly. X to the 8 over 8 plus c prime. 8 goes down, it becomes x to the 7 over 8 plus c gives you 0. Cancel out, it gives you x to the 7, check mark. Make sense? So you can always check yourself. We will be doing product rules and stuff. I'm doing all of this. You can always differentiate really fast and check that your exam answer is correct. That's a pretty cool part of it. And that's why people like integration. So we did power rule. Now, the same way it works with all kind of awkward powers, not necessarily nice one. 2.17 dx, doesn't matter. Formula is still the same. X 2.17 plus 1 is 3.17. Immediately divide by the same thing, don't think about it twice, and add c. Does that make sense? And you can always check if it's true or not. Differentiate, decrease by 1, it will cancel out. So that is power rule. How about square roots? Remember, you always struggle differentiating square roots? Let's learn how to integrate square roots. For example, what is the integral of a square root of x? Maybe take a pencil. Let me make a recommendation. Maybe take a pencil, I always say that, and write it as x to the 1/2. And that's not what's different than 2.17. Anyone here want to say? ln is only for 1 over x though. Only for 1 over x you do log. This one is still power rule. So x to what power?
Negative.
You adding.
Oh,
Adding.
How? 1.5.
1/2 plus 1 over 1/2 plus 1 plus c. Very fast in your mind. 1/2 plus 2/2 gives you 3/2. So it's x to the 3/2 divided by 3/2 plus c. This answer looks very ugly. So usually people remember, you flip the fraction right away. If you have x to the 3/2, multiply by 2/3 plus c. Does it make sense? When you divide by 3/2, you multiply by 2/3. Reciprocal, or multiply by the reciprocal. That's power rule. How about negatives? X 1 over x cubed. We're going to get to logarithm soon, but it's still not logarithm yet. 1 over x cubed. Take your pencil and rewrite it as x to the minus 3. Same idea. X minus 3 plus 1 over minus 3 plus 1 plus c. What is the answer? What is the answer?
Negative of x to the negative 2.
Negative 2 divided by negative 2, right? So either I can take out the negative 2 or not. Both are good. Then people like to rewrite 1 over minus 2x squared plus c. Is it correct or not? Agree or not agree? That makes sense, right? So like these classes should be very good, very fun. After Halloween, probably it's hard to make any. Did you bring any chocolate? I thought we agreed to bargain, you know. Exam on Wednesday, I eat chocolate, no? Did I forget to mention that? You're so greedy. You know I like chocolate. Anyway, e to the 4x dx. Who is brave enough to give me the answer right away? Copy. We do not do plus anymore. That's integration of exponential function. Same idea. You copy, and then your mind says, oh, there's a chain rule there, because 4 is hidden inside. Chain rule usually says multiply by 4, but we undoing chain rule. To undo chain rule, we're going to do what? Divide by 4. Plus c. Make sense? So copy, figure out the exponent. If you differentiate, 4 pops out. If you integrate, 4 goes to the denominator. Like so. And you can check. Let's do the check one more time for this particular function. You can check what is derivative of 1/4 e to the 4x plus c. It should give you e to the 4x. Let's check that. Prime. 1/4 stays. E to the 4x is e to the 4x times, that's going to be on the exam on Wednesday. What is derivative of e to the 4x? E to the 4x times 4, based on the chain rule, plus 0. 4 cancels out with 1/4, and the answer matches e to the 4x, check mark. So undoing is going well, for now at least. Undoing is going well. Yeah, questions or stretching? No problem. One more interesting one. How about this one? Let's make it confusing on purpose. I don't know, pi over x dx. Who is ready? Pi over x looks super weird. What do you think about that? Pi ln x, so fast. Did you guys get it? Pi stays because of the formula which I showed at the very beginning. As always, the constant can be kicked out of the integral. So to be honest, this first formula is just k being outside, and you have an empty integral. Empty integral is integral of 1. What gives you 1 when you differentiate x? So it's going to be k times x. That's kind of how it works. Here in this example, you have pi over x. You can always take this pi as a constant and kick it out. It's going to be pi. I'll be doing this quite a lot. 1 over x dx. But 1 over x is a logarithm when you integrate it. So it's going to be pi natural log of x. Find the mistake in this answer. Mistake, find it. Yes? Absolute value. That is important because x can be like minus 13, but logarithm of minus 13 doesn't exist. To fix that, you have to put absolute value. The domain of the integral is too broad, so we're cutting it for the logarithm function to make sense. Pi natural log of x plus c. Does that make sense? What do you think? Yes?
You have to keep the integral sign after the pi and answer.
Very good question. You don't write integral the moment you integrate it. So just like you stop writing the prime when you differentiate it, you stop writing integral when you finished integration. Integral of 1 over x is log, and that's why integral sign disappears. Yeah, that's a very good question because people keep doing both. Don't forget, when prime sign disappears, you differentiate it. Integral sign disappears, you integrate it. Properties or rules. Okay, integration rules. Integration rules. There will be very common rules. For example, the one we just showed you, integral k f of x dx. Just like with differentiation, if constant is multiplied by a function inside of the integral, you can kick it out. That's very convenient. We do it all the time. K times integral of f of x dx. That's exactly what I just did in my example. Kicked out the constant. Because with the derivative, you can do that as well. And the other one, remember with differentiation, what did we do when we had plus or a sum or a difference of two functions inside of the derivative? We could differentiate each. Same idea with integration. You will have one function integrated first, if you want to, plus or minus another function integrated second. Maybe one more function, and so on and so on. Sum and difference rule. And after this property, it gets super fun. So let's do that. So the moment you learn those two, that becomes extremely interesting. Right? Yes. I was giving away candy yesterday at Halloween, and I asked some of my students in Calculus 3 class in the chat, how should I scare kids when they pass by? So I have Russian music playing, right? I'm yelling at them for fun. They're like, woo, and stuff. They told me, show them triple integrals we are suffering right now with. And I'm like, yeah, that's true. Triple integrals are actually very fun. They're doing right now their last homework for triple integrals, dx, dy, dz. And we have triple integrals right now, d rho, d phi, d theta. So they're suffering with this. That's Calculus 3 class. Multivariable calculus. It's very fun. But we just need to learn at least one-dimensional integral in this class. Examples. And these examples are super fun. I will teach you how to do integration fast. 3x to the 5 plus 7x to the 2 plus 8 dx. Some people put parentheses, some people don't. There's no international notation requirement to put parentheses, so people don't do it. Because if you don't put parentheses, you still know when the integration started and when the integration ended, where the x is. So that's why it's not necessary. But visually, you can do it if you want. So property number 2 says you can write down integral of, you can do small integrals here, here, and here, right? Nah, don't do it. In your mind, you just integrate step by step. Integral of 3x to the 5. Let's say it out loud slowly. Integral of 3x to the 5. I'm not writing integration sign anymore because I'm integrating right away. It's going to be, yes?
3x divided by 3x to the 6 divided by 6.
Perfect. All agree? 3 survived because it's a constant. Property number 1 says you can kick it out, so it will be there. And it's multiplied. It's your rate. Rate will survive when you differentiate or integrate.
Which summarizes actually all to 1/2 x.
Right? So x to the 5 becomes x to the 6 over 6. Plus integral of, let's say it out loud, integral of 7x squared. Anyone else? 3 over 3. Perfect. Good job, you guys. More confidence. Amazing. 7 stays. X squared becomes x cubed over 3. And you can always check. Differentiate x cubed over 3. 3 goes down, cancels out with 1/3. It becomes x squared. Plus, what gives you 8 when you differentiate that?
There was
8x. Did I forget anything?
yes.
Plus c. The thing is, you're supposed to have plus c from each. So students sometimes ask why it's not plus 3c or something like that. We collect all the possible c's into one and call it capital C.
I guess the actual reason is because you can't triple infinity. Because C could be literally anything. And you can't triple
It's anything, yeah. We actually will.
Because C can be anything. And
Yeah.
tripling infinity is just infinity.
Yeah.
It's really not
It
really
makes sense,
triple.
yeah.
C could already be that.
Let's simplify. Yeah, good point. Simplify, and it's going to be, what is it? x6 over 2 plus, you can do 7/3 x cubed plus 8x. There's barely any simplification here. But if you differentiate this, that's the thing, you can always check yourself. Okay, that's going to be the last time I'm checking, honestly. Let's check. I want to differentiate this answer. X to the 6 over 2 plus 7/3 x cubed plus 8x plus c prime. What should I get? I hope to get everything inside of the integral, which was this part. So let's check. X to the 6 over 2 gives you what?
3x.
6x to the 5 over 2, which is 3x to the 5, right? Now, 7/3 x cubed gives you 7/3 3x squared. 8x gives you 8. C gives you 0. Simplify. 3x to the 5 plus 3 cancels out with 3 gives you 7x squared plus 8. Matches? I don't know. Let's check. 3x to the 5, 7x squared plus 8. Matches. That's a cool part. On exam 3, you can check your answer. How amazing is that? One more example. People are like, I'm tired. Stay a little bit awake, a little bit more. 2e to the 6x. Let me ask people at the end of the class. 3 over x plus 7 over square root of x dx. If you want visually put parentheses, you can do, some people put brackets also for fun. I usually don't put anything. Europeans, I think we don't put anything. I don't know why. Okay, so again, you break into each integral, but it's too slow. You should learn how to do fast integration. Just integrate piece by piece. Who wants to tell me what is the integral of 2e to the 6x step by step? And yes, you guys.
What if you just do that to the 6x?
2 times e to the 6x. Very good, but something is missing. 6. Something happening with 6, right?
Oh yeah, you divide by 1/6.
Divide by 1/6. Divide or multiply? What do you guys think? Divide, because channel when you differentiate says multiply. We're undoing it, so divide. Remember that, okay? When you differentiate e to the 6x, you multiply by 6. And that's why if you don't remember this, now it's very confusing. You should be prepared for the exam 2 right now. Derivative of e to the 6x is e to the 6x times 6. But integral divide. How about minus 3 over x?
3. Wouldn't that just be 3 ln x?
I don't know, maybe. Who wants to say? Anyone? Anyone at the back, you guys? Guys and girls? Yes? You guys at the corner, I know you know. You know, I know you know, and you know that I know that you know. Yes, well, 3, I heard 3, that's good. What else? What is 1 over x? ln. So ln x, and don't forget absolute value.
Oh, you're right.
Not too bad. 3 ln absolute value x. The last one looks hard, so if something looks hard, I will take a pencil. As a student, I would write down somewhere over here, but I like making good notes for myself. So I will rewrite it as a 7x to the what exponent? Negative 1/2, exactly. Now, the property is exactly the same. 7x to the minus 1/2 plus 1, which is, well, let me write down, I guess. Minus 1/2 plus 1. And then don't think about it. Just immediately copy it at the denominator. That is a power rule. in progress, plus c. Plus c equals, simplify to get nicer answer. E to the 6x over 3 shows up from canceling out 2 and 6. Minus 3 ln absolute value of x. And that is part of the formula for integral of 1 over x is ln. Maybe write down 3 integral 1 over x dx. This is what's happening for the second part. Well, it's minus actually, but it's fine. Finally, plus 7. Maybe take a pencil again and simplify this separately. This is x to the what power? 1/2 divided by 1/2. So it is 2x to the 1/2. We're just simplifying the result of integration. 2 times 7 is 14 square root of x plus c. That is the result of the last part in green. 7 is multiplied by 2 gives me 14. X to the 1/2 is square root of x, which you don't have to write, but why not? This is what we called fast integration. No formula separately writing, it's too much. You just do it right away. Right away. Let's do one more, or maybe two. Let's see how you work with radicals. That's your least favorite, to be honest. Students don't like working with radicals, so I try to show it more before each exam. What is the integral of 3 over x to the 5 minus a third root x to the 4 plus 4 over x dx? If you want, you can put parentheses. Slowly. So is your integral sign beautiful? Make sure your integral sign is beautiful. Some people don't care, but actually you should learn to make it beautiful. Let's see. 3 over x to the 5. I don't know any of this. So let's rewrite it as much as possible. So since I want to just rewrite, I will keep the integral sign running because I'm not integrating yet. I just want to rewrite. So integral is still there. 3 is multiplied by x to the minus 5. Okay, that's going to be power rule. Minus x raised to the what? 4 over 3. If you don't remember this, this is how I try to teach. 4 is a bit higher than the root. So 4 goes to the numerator. 3 is lower because it's in the root, so it goes into denominator. Plus, do not rewrite 4 over x. It's just 4 times 1x. Integral of 1x is log. So keep it. It's one exception. When there's a power minus 1, you do not touch it. It gives you log. Now, I am integrating this nicely looking integral. And that's why integral sign disappears now. Integral of 3 times x to the minus 5. Do you understand? Okay, let me do it like this. It's x to the minus 6 or x to the minus 4?
To the minus 4.
To the minus 4. Do you agree? Because we're adding 1. We're not subtracting 1 anymore. So it's minus 4 and you immediately divide by minus 4. Makes sense? You're adding 1 to undo power rule from differentiation. Minus x to the 4/3 will be 4/3 plus 3/3. So it's 7/3 multiplied by 4/7. 7/3 multiplied by 3/7. But I don't want to skip too much, so I will divide by 7/3. But now remember, you always multiply by the reciprocal. So it's going to be times 3/7. Plus, what is 4 times 1 over x? 4 ln absolute value of x plus c. This is the answer without simplification. But we're going to simplify right now. If you mess up in your homework or exam 3 and write down this as a 4x to the minus 1 plus 1 over minus 1 plus 1, you will notice your mistake. How? It will get over 0, right? And that's why it doesn't exist. That's why power rule does not work for x to the 0 over 0. Like, what is that? And that's why we don't do it. That's why we use logarithmic function to avoid this over 0 thing. So if you ever forget and use power rule, you will notice it. And it will give you a hint. Oh, don't do that. Use logarithmic function. It's the exception. Equals minus 3/4 x to the minus 4. I like to keep it negative. Or you can divide if you want. Minus 3/7. I told you we're going to multiply by 3/7. X to the 7/3. It's always the flipped fraction in front. Plus 4 natural log of x plus c. And this is nice, finally looking answer. Last one. But let me ask, how do you feel about this? Yes?
If you answer on the test and I'll simplify the
I'm fine with the written part. With the multiple choice, you have a list of things to choose from. So yeah, it's a good question. If I'm grading, I really don't care, to be honest. And I don't like when you give me like 3.14 instead of pi. That is offensive to pi. You know, like pi is a secret thing later. Like, don't touch it. But everything else is fine. So, last question will be number 4. This will be interesting for you. So, what is the integral of 2x plus 3 squared dx? Pom pom pom. There's some kind of chain rule going on which we need to teach you how to undo it. And we will teach it to you very soon using U substitution. But if you don't know it, what are your strategies? What do you think we should do?
Just square the whole thing.
Just square the whole thing. Using formula though, so don't just put 2 everywhere. You see, if I keep rewriting the integral sign, it means I'm not integrating yet. I'm rewriting it. So, rewrite. This is a formula, square of sum. Square of sum says square the first term plus double product of the first term and the second term. 2 times 2 is 4, 4 times 3 is 12x, plus square the second term, 9. So you don't just put square everywhere. It's a square of the sum formula. See lecture 0. I always refer to that.
And that's all the end.
Okay. Anyone at the end want to feel super proud and tell me the result of this one? Anyone here? You guys?
4s and then to the 3rd over 3.
3/3 over 3. Amazing. What else? More. I need more. Keep going. 12x gives you what? Yeah, something about squared. Because it's like 1 over here, right? 6x squared is a good answer, but let's explain why. Can you tell me why? 12x to what? 2, and then don't even think about it, just divide by the same thing. So x to the 1 have the same, that's not prime, that's 1. It's fine. X to the 1 increased by 1 gives you 2, divide by 2. And 9 gives you, if you ever forget, just ask yourself, what is derivative that gave me 9? That's 9x. What derivative gave me 12x? 12x squared over 2 plus c. And then, like you mentioned, we could simplify 12 and 2. 4/3 x cubed plus 6x squared plus 9x plus c. If you differentiate this, it should give you everything inside of the integral. And that's how you can check the mistake. And it's true, 3 goes down, cancels out with 1/3. You get 4x squared. 6 times 2 gives you 12x plus 9. Matches. Good job, people. Wednesday, don't be late, be prepared, come in. I will come early for the last moment questions, but it should be fun. We should do well.